All right, so section 2.2 is talking about histograms, frequency polygons, and time series graph. But the biggest piece in this one is histograms. I can basically guarantee you that Snow is going to ask you, sometimes maybe more than once, to be able to construct a histogram for our data sets. So we're going to kind of walk through this. The histogram is like a bar graph, but the bars are adjoining boxes. And the widths of the bars are the same throughout. With the histogram, your horizontal axis is the data, and your vertical axis is the frequency or the relative frequency. Okay. So as we do this, your data is the x-axis, and your y-axis is the relative frequency or your frequency. So to construct a histogram, you have to decide how many bars or intervals or classes represent the data. Now, when we do this on a test or our Snow's exams, they're going to tell you how many classes or how many bars you need to create. But most of the time, it's going to be between 5 to 15 bars so that it doesn't get too overwhelming. Okay. So you have to choose the number of bars or classes that you're going to need. And then we're going to adjust our x-axis so that we have a starting point that's based off of our smallest value and an ending point that's based off of our highest value. This adjustment means that when we have a data value that falls within a class or a bar, it's going to fall right in as close to the middle of that as possible. It also starts to eliminate the possibility that a data value would land right on a boundary or like the upper bound or the lower bound of a class or of a bar. So the way that we do this is you look at your two closest data values that are not the exact same, but just the two that are closest. See the distance that they are away from each other, and you're going to cut that in half, and we're going to shift the lower boundary down that much and the upper boundary up that much. We're going to do this in just a second. All right, so this is example 2.8. We're going to use this example to talk about what our adjustment is going to be. So we're going to use 6 bars or classes as we make this histogram. But before we do that, we need to adjust our start and stop. So if we look at the closeness of all of our data values, there are some that are the same, but we're not going to use that. We just want the ones that are different. And it looks like all of these are at least 1 unit away from the next. So we've got that 1 unit, and we're going to cut that in half. So that means that we're going to go one half of this unit to the left for our starting value, and then 1/2 of that same unit to the right for our ending value. In other words, because we start at our data value being 1, on our histogram, we're actually going to start at 0.5. Because if we have 1 unit's difference between these, 0.5 we're going to shift our starting point 0.5 to the left and 0.5 to the right. So our x-axis is going to start at 0.5, and it's going to end at 6.5. So on our x-axis, we're going to start at 0.5, and it's going to end at 6.5. So that is our adjusted starting and ending point for our x-axis on this histogram. All right, so because our values were 1 unit apart, we're going to adjust the starting point by the 0.5 and the ending point by 0.5. All right, so now we have to find out the width of our bars. So we know we're going to have 6 bars, and the way that we do this is we take the adjusted ending, subtract the adjusted beginning, and then divide it by the number of bars or classes. All right, so once again, to calculate the width of each bar or class, you're going to do the adjusted end value and subtract the adjusted starting value, and then divide by the number of bars or classes. So for ours, our adjusted ending value was 6.5, our adjusted starting value was 0.5, so we subtract those, and that gives us 6, and then 6 divided by 6. Now remember, 6 was the number of our bars, and that tells us the width of our bars is going to be 1. So we go down to our histogram, and we know our starting point is 0.5, and now each bar is going to have a width of 1. All right, so we do 0.5 plus 1 gives us our next boundary of 1.5. Add another 1 and we get the next boundary of 2.5 and the next boundary of 3.5 all the way up until we hit our ending point of 6.5. So then we look through the data and see how many data points fit within this class. So we had 11 ones, and 1 is right in the middle of our the width of our class. So we have 11 ones, we had 10 twos, 16 threes, 6 fours, 5 fives, and 2 sixes. Okay, so we're just graphing the frequency and making these classes be right next to each other. So that's how you build a histogram. Now sometimes a value can land on a boundary, and if it does land on a boundary, so if a data point falls on a boundary, then it's going to go into the class that is to the right of what that boundary is. So if it falls on a boundary, it's going to go into the group to the right. All right, so now we're going to talk about frequency polygons, and they are pretty much like line graphs. So we've already talked about a line graph, but the difference between a frequency polygon and a line graph has to do with making an extra class so that it hits the x-axis. All right, so on this one, the frequency polygon, we have graphed the middle of the basically of the classes because they have a lower bound and an upper bound, and so we're graphing, or we're choosing the x-axis to represent the middle of that, and then we create a class that is lower than the given data and another class that is higher, so that it actually comes down and touches the x-axis. So down in here you'll read that these data points don't even exist in the data set, but it allows us to take this frequency polygon and have it touch the x-axis. Okay, so one of the things that we like to do with a polygon would be a frequency polygon is to compare them, and you can overlay them. All right, so this is an example of overlaying the frequency polygons. So one of these is the final grade, and one of them is the final test grade. So the grade that you got on the last test versus the grade you ended up with at the end of the course. And then you can see the differences and similarities in patterns with these two overlaid frequency polygons. A time series graph is basically when we use the horizontal axis to plot time, whether it's in date, years, whatever it is, but the x-axis is our time, and then the vertical axis is used to plot the values of the variables. So that's a time series graph. And here's an example of a time series graph. So we've got our years down on our x-axis and the annual consumer price index on our y-axis. And the reason that we'd want to use a time series graph is because it's easier to see trends and spot patterns. So that's why we use, or when we would use a time series graph.